All right, today we're going to be looking at inside your computer. So this is going to be a quick demo on how to go about upgrading your computer. This is desktop specifically. Laptops are more complicated as far as upgrading goes. So we're not really going to cover that. Some of it may be applicable to laptops, and I'll point that out. But for the most part, we're going to be talking about your desktop if you still have one, and some easy ways you can update it. We'll cover all the different parts inside and how easy it is to update them, what you really would want to update, the benefits of different ones, and some of the good manufacturers you can look for in updating your computer hardware. So here's just a quick overview of all the different types of parts in your computer. We're going to go over each of them. You have your CPU, RAM, storage, graphics card, optical drives a lot of times, power supplies, and then of course the motherboard, which kind of ties it all together. So first one we're going to start with is the central processing unit. This is more or less the brain of the computer. This is what does all the thinking, does all the calculations, and is really the backbone of all the stuff that goes on inside your computer. It's what's receiving all the instructions from the software and executing them, and it's going to also command all the components, the other components we're going to talk about today, command them and how they're going to operate, and what they do from moment to moment. More or less, we're going to measure the CPU as far as performance goes in clock speed, either megahertz or gigahertz, depending on how good the CPU is. Usually nowadays it's all in gigahertz. You don't see so many in megahertz anymore, just because CPU technologies come far enough that they're all up in that range by now. This is going to be one of the biggest factors in the speed of your PC that you can really touch into and fix yourself for an existing computer if you're not building your own from scratch. But it can be very expensive, or depends on really how far you want to go. You can get CPUs anywhere from like $100, well over $1,000, depending on the level of performance you need out of it. And in many cases, you can get a reasonable one for less than $500 to get an upgrade out of your computer. But compatibility is very important. You need to make sure that if you have an older computer, the new CPU you may be getting is compatible with the socket that's on the motherboard, so that you can actually install it. And there's some other compatibility issues that can come up, whether or not there's enough power to support it, things of that nature. So you have to be careful when you do an upgrade like this. If there is compatibility issues and you want to get something newer and your computer is just not compatible with it, it can be very expensive because you'll need to swap out multiple parts, not just the CPU itself. Like I mentioned, performance is measured in megahertz or gigahertz. It's going to be how many operations it can do per second. And it's going to be one of the biggest factors in speeding your PC up. Some of the common manufacturers, the two big ones you'll see is Intel and AMD. Intel is obviously the larger the company. You've probably heard of them at the very least. They have a much wider range of products they offer, probably a little bit better reliability than AMD, but AMD is much less expensive, and they're also up and coming now. You'll see a lot of products nowadays that run with AMD processors and AMD technology, and they're also good. But either of these two companies will be able to provide a good product for you, so either will work. The next one that you might want to look at, this is a really easy one to fix. This is your RAM, random access memory. This is the memory that your computer is using moment to moment in order to make all the calculations and run all the processes that are going on in your computer. It's just temporary storage and workspace. Think of it as kind of like your desktop. All the things that you're doing at the moment, they all are right out in front of you where you can easily access them quickly and do what you need to do with them. That's more or less what your RAM is. Depending on the type of RAM you have, the RAM will run at different speeds. There'll be different speed values for the RAM, also measured in hertz, just like your CPU. And obviously the higher that is, the faster you can access that memory. And then the more memory you have as well. And like I mentioned, there's a number of ways you can measure the performance of the RAM you have. One, the capacity, how many gigabytes of RAM you have. It essentially works the same as your hard drive, how many gigabytes of space you have for memory. And the other is, like I just mentioned, the access speed of the RAM. How fast can it insert and pull data out of that RAM memory? And that's generally measured in megahertz, although it's up in the gigahertz range nowadays as well. Adding more RAM can really improve the performance of your computer. If you don't have enough RAM, it doesn't have enough operating memory to really carry out all the tasks you're asking of your computer. So if you're running out of available RAM, it'll start to slow everything down. It doesn't have enough workspace on its desk, so it's got to finish one thing before it can start to pick up the next thing you've asked it to do. So adding more RAM can alleviate that issue and allow your computer to do more at once. And also changing the access speed. If you have a higher access speed to the RAM you have, that'll allow it to do things faster as well. This is very easy to upgrade, and it's very inexpensive. You can buy a lot of RAM very cheap nowadays, and it's very easy to pull in and out. Usually just open up the side and slide a new card into one of the RAM slots, and it's equally easy to do on a laptop. Laptops a lot of times nowadays will have a plate right on the bottom of your laptop that you can pop off with a screw or two, if any screws, and then plug in RAM there as well. You do need to buy special RAM for laptops, though. They're a different form factor. They're much smaller than RAM for a desktop, so make sure that you're buying the right kind. You should be able to look it up in the system's description on your computer what kind of RAM you have, or you can call your OEM and find out, or Google it if you're not sure. But like I said, there's minimal compatibility issues here. It's more or less standardized, and it's very easy to install more RAM or new RAM. Here's just a number of the manufacturers of RAM. There's a lot of them. Tons of people make RAM nowadays, and these are all really great companies. Any of these you can be, fairly assured you're going to get a good product. I personally use a lot of Corsair products, but OCZ, PNY, Kingston, those are all great products as well. But any of these guys will get you a good product. You can also buy off-name RAM for much cheaper, probably like a tenth of the price of any of these products, but you don't necessarily have a lot of the reliability that comes behind a name like this. Data storage is probably what we all think of most. This is how much storage space you have for things like your pictures, your video, your software, the operating system itself. Every computer, laptop, desktop will have some kind of data storage drive, and they come in two types really. You have your hard disk drive, which is more traditional. Most computers nowadays will have those. But nowadays you have also solid state drives, and they have some advantages over the more traditional hard disk drives. Hard disk drives are cheaper. They've been around longer. The technology's been around much longer, so that they've had time to improve the manufacturing, really lower the cost of those. So you'll get more space on a hard disk drive for less money, more gigabytes per dollar essentially. But it can be kind of fragile. If you have a hard disk drive and you drop your laptop, it has all these little platters inside which can be easily damaged under a shock load. So you have some problems with damage in that case. The solid state drive is much more expensive. It's a fairly new technology comparatively to the hard disk drive, at least in this application, but it's much more robust. There's no moving parts inside it. You can drop a solid state drive and you'll have no damage to it. It's less susceptible to temperature changes, so if you leave a laptop in the car overnight and it's really cold out, you can potentially get damage to that as well. And it accesses data much faster than a hard disk drive, but like I said, much more expensive per gigabyte for a solid state drive. But you'll typically have one of these two. Solid state drives are more prevalent in laptops nowadays than HDD, than they are in desktops. You can get either. The two big metrics that you're going to look at with hard drives is either going to be the actual storage capacity, how much data storage do they offer, and then the transfer speed. And that's usually in gigabytes per second. How fast can they move files around on the drive as well? So you want to have kind of a balance of both of these. This is also an easy upgrade to add more data storage, especially in a desktop. You usually have a number of unused bays inside. If you ever take the case off or the side of the case off to your computer, there'll be tons of space for new drives in there. Not quite so with laptops. A lot of times they don't have extra bays in laptops, but you can get external drives and get the same kind of upgrade. You just use USB connectivity instead of actually plugging it inside. But the one exception to how easy that is if you're going to be upgrading your boot drive, the drive that has your operating system on it. If you're going to do that, you have to either clone the drive over with special software that often comes with drives now, or you need to reinstall Windows and all of your software, which can be a pain, but it can be done without actually impacting it. It's just a little bit more involved, and you may or may not want to do it yourself. You might want to get somebody who has a little bit more experience with that kind of upgrade to help you out with it. But it is definitely doable. And here's a few of the common manufacturers for the different types of disk drives. You'll notice that a lot of the folks who build solid-state drives are the same people who build RAM, because they're very similar technologies. So Corsair is a very good company with this. Samsung is also a very good company with solid-state drives. But any of the four will work. And then hard disk drives, there's tons of manufacturers, but these are the three that you'll see most often: Toshiba, Western Digital, and Seagate. Any of those three will work well. And one thing I didn't have here, which is a little bit more, a little newer, it wasn't out when I actually made this slide package. They also have hybrid drives now that combine the best of both worlds of hard disk drives and solid state drives. They'll actually have a small capacity solid state drive on the disk, and all the files that it senses that you're using most often, it'll migrate to that solid state drive, so it can access them very quickly and speed up how fast it uses the software or whatever those files are for. And then all of the low access frequency, like movies or music that isn't getting accessed a lot, it'll migrate to the bulk storage on the hard disk drive. So it'll actually give you kind of the benefits of both, much less expensive than a solid state drive with much more space, but it still gets some of the benefit of access speed that you get from a solid state drive. So that's a somewhat newer technology that's available now. I forget who makes it. I think Western Digital is the only company that I've seen that actually offers that recently. Next up is the graphics processing unit, GPU, graphics card, video card, however you want to refer to it. This is what's going to process all the visual outputs of your computer. It's going to translate everything into a visual display that goes to your monitor, or your TV, or your projector, or whatever you're displaying with your computer. This can be a standalone device like the card you see here. It's its own device, or it can be a part of the motherboard, which we'll discuss later. That's called an integrated graphics card. A lot of them nowadays support multiple monitors. You can see on this one it's got 2 ports in the back, so you can set up more than one monitor. You can set up 1, 2, 4, depends on the graphics card and how many you have. You might have more than one graphics card in your computer. There's systems that do 4 or more graphics cards in one computer if you're doing high-end gaming or anything of that nature, which I mentioned down there. This has a number of metrics you're looking at. You're going to want to look at the clock speed of the GPU, how fast it can do its calculations. It's similar to a CPU in that respect. It also will have onboard memory, much like RAM. So you're interested in the capacity of how much of that it has to access, and the clock speed of that memory. So there's a lot more going on here with this piece of equipment. A lot of times, if you're interested in upgrading one of these, you're doing one of 2 things. You're doing either graphics development, gaming, something of that nature, in which case you might want a high-end graphics card. There's a few different types of form factors, I won't get into it, but on the other hand, if you're just kind of looking at mid-range use, you're doing some gaming, you're mostly looking at videos, you can go with a mid-range card that maybe is more suited to looking at HD video rather than playing video games. And those are much less expensive. It's not a very difficult upgrade, at least in desktops. Laptops, a lot of times you can't actually upgrade this, or it's very difficult to. But in a desktop, it's pretty easy. As long as it has the right port on the side of it, you can get any of a number of manufacturers. They all have a standard port inside. They're usually AGP is very old. That's not very common anymore. A lot of times now they'll be PCI Express. And you can just plug it right into the motherboard, which we'll talk about later. The price range varies. You can get a mid-range card between around $100 or less. Maybe a little bit more. High-end cards go up over 500. Some go for over 1,000, depending on who makes them and what they're designed for. There's some specialty cards out there that are like $1,500, but unless you're into some specialty stuff, you probably don't need to worry about it. And as I mentioned, some laptops don't have the capability of upgrading. There's really mainly 2 graphics card designers, but you won't usually see them associated as the actual manufacturer. They make the design of the card, and then they farm out the actual production and sale of that card to a number of companies The two big ones are ATI and NVIDIA. They're the big guys in the market. And then what they do is they license the production of their cards to all of these companies you see here. So a company like Asus or Gigabyte may actually make both ATI and NVIDIA cards, but in general, any of these manufacturers will provide you with a good product. I particularly like EVGA. I've also used XFX. They're both very good companies, good customer support, but any of them will do well. Optical drives is kind of self-explanatory. They've been around a long time. Everybody more or less understands them. CDs, DVDs, Blu-rays nowadays. They're in almost every computer, whether it's a laptop or a desktop. Some laptops nowadays are actually getting rid of them. They don't necessarily have them anymore. A lot of the lightweight netbooks, things like I think the MacBook Air doesn't have one. But most computers you have will have them. They're fairly inexpensive. They're not really anything that will improve the performance of your computer, but the only upgrade I can think of really nowadays is if you don't have a Blu-ray drive and you want to watch Blu-rays on your computer. That'll be the big one that's possible on a desktop. You can buy Blu-ray drives now. I think they're well under $100 now. They used to be fairly expensive, but it's much cheaper nowadays. That Blu-ray's been out for a number of years. The power supply isn't something that really gets upgraded a lot unless you're doing a lot of other upgrades to your computer. Your computer itself will come with a power supply that's good enough to operate everything in your computer plus a little bit more. If you're doing a lot of upgrades, going to like high performance cards, much higher performance CPUs, you need to make sure that this is providing enough power to operate all the parts that are in your computer. You can have some serious problems if you don't. There's issues like system instability, crashes, and you can even damage the computer itself, fry circuitry, and create actual hazards if you're overloading your power supply unit. Some cheaper models have much less protection in them to prevent things like that. Higher-end PSUs will be able to protect things like that, but unless you have one of those, you can really ruin a lot of your equipment if you're not careful. So it's always important to make sure you have a large enough power supply, and it's going to be rated in watts. You're going to make sure it has enough wattage to cover all the equipment that's being used. And like I said, it's not necessarily something you need to do unless you're upgrading a lot of other equipment. These four guys down at the bottom are some of the big names in manufacturing. Corsair makes good products. Rosewood makes good products for this. I haven't used C-Sec and Antec before, but they're also very well-rated manufacturers. Like with the other slides, any of these guys will give you a good product that's safe and will do good for the money. Last but not least is the motherboard. This is what everything plugs into, for more or less. This is kind of the heart of the computer. Everything goes through this. The CPU plugs into this, the GPU goes into this, all of the hard drives, RAM, everything plugs into this piece of equipment. This is kind of the central portion of the computer. You need to have one of these. And it's probably one of the hardest things to upgrade because there's so many compatibility issues you have to keep track of. If you upgrade this, you might need to get a new CPU. You might need to get a new, CPU is probably the biggest issue you have with this. The most important part of this is the chipset. That's part of it. You have the Northbridge and Southbridge. This is going to be controlling things like how the CPU operates with all the other equipment. How the GPU works. Sometimes they'll have a dedicated GPU as part of it. That's what I was talking about earlier with an integrated graphics card. But that's controlled all by the Northbridge. The Southbridge part of it handles all the rest of the equipment, storage drives, optical drives, and other interfaces like the network drives. So these aren't the CPU. The CPU does a lot of the actual control of the computer, but this does a lot of the background work, making sure all the parts work together. There's really no performance difference with chipset. It's usually just different companies that make them. NVIDIA makes a chipset. I think they still call it Enforce, I'm not sure. ATI also has their own, and they're optimized for certain products, but you'll be able to use most hardware with either type of chipset. They just may not be optimized for one another, but it shouldn't cause any huge issues. But other than that, the only other real things on the motherboard you have to be interested in is the type of sockets that there are. Make sure that it has the CPU socket for the type of CPU you want. That's probably the biggest one that people run into. Make sure that if you buy an ATI CPU, it has the right ATI socket. Because if you get an Intel motherboard, you're not going to be able to plug your CPU into it, and you're out of all the money you spent. Hopefully, you can return products, but it should be something that you research up front. You want to have the right socket for your CPU. You also want to make sure you have enough expansion slots, so you have enough slots for all the video cards, any other cards like LAN cards or sound cards, things like that. You have enough room for all of them. Cooling technology is also something to keep in mind. You want to make sure everything is cool enough to operate safely. This is just some of the parts on it. I won't talk about all these, but you can come take a look at this. I believe it's going to be on the website, so if you're interested, you can take a more detailed look and see all the different parts of the motherboard. This is, like I was talking about before, compatibility is a big part of this. You want to make sure that you're not ruining any of your compatibility when you're changing parts. So just be careful. Make sure you research thoroughly when you're changing anything like a motherboard.